Hello, so let's look at number 2 from year 2011, Form B. So I'm going to give you a little bit of time for you to look at the question first. So here we have, when time t equals 0, filled to capacity, that means the initial value was 12,000. Now, r of t is not just any function, but it's the rate where the water is draining out. Now, first, let's look at A first. Is R continuous? In order for you to understand whether something is continuous or not, what we need to do is this. We need to figure out the limit of R of t as t approaches A. Is that in fact equal to R of A? Now, since especially in piecewise function, in order for us to calculate this one, we have to look at we have to break this one down into 3 different components. In order for the limit to exist, we gotta have the limit of R of t as t approaches, in this case 5, so 5 from the right has to be equal to limit of R of t as t approaches 5 from the left, and that has to be equal to R of 5 or so. Now, in order for us to calculate this one, I'm going to try to put each one into the equation calculator, so we'll see what happens here. I'm going to erase all of them, and then the first one I'm going to put it as 600t. I'm just going to put it as x over parenthesis x plus 3. So that's the first expression. How about the second one? It is simply 1000 and e to the negative 0.2 x. So now we are looking for the value 0 and up. So I'm going to set the window as minimum as 0. And how about maximum as 10? That's fine. And then I'm going to go for zoom fit, which is 0 right over here. Or I can just bring it down. Okay, zoom fit. What it does is that it keeps the x value and then changes the y value for you. Now what I'm going to do is this. Since I'm looking for limit as x approaches, t approaches 5 from the right side, that means we have to look at this portion of the function, which is the bigger one. So second trace, this gets us a lot of possible calculations that which we can do. So what I'm looking for is the value, so why don't I just press 1. X value has to be equal to 5. Then when x equals 5, it was 375 based upon the first expression. So then first expression basically means right here, when t is less than or equal to 5. That means, based upon this picture, we can say that this will be equal to 375 and 375. We just have to figure out the first one, which belongs to the second expression. Now, here we have, for the second expression, we end up getting something quite interesting. Now, we end up getting this value. Here we have 367.89. So in fact, this one is not equal to each other. That means there is no limit exist in that about that particular point. So therefore, we realize that this piecewise function is not continuous. All right, let's look into B. Find the average rate. Notice that this was already rate. That means what we can do is this. given average rate, in order for us to, given the rate function, in order for us to find the average rate, what we have to do is from 0 through 8 of r of t. Divide by 8 minus 0. But as you can see, r is the piecewise function, so therefore this becomes up to 8, right? So we're going to have 0 through 5 because that's one piece of function, dt, plus 5 through 8 of r of t dt. And divide whole thing by 8. Then let's look at the first portion. We're going to calculate the integral number 7. Now, lower limit would have been equal to 0. And as you can see from the top of the screen, we are looking at the function, the first function, y sub 1, 600x, which is a correct one which we want to work on. Upper limit was 5. Then according to that, this would have been our calculation. So therefore here we have 1234.5 or 73. Now, on the calculator, second portion is this. We want to integrate the value number 7. Now that's not the function, but yes, y sub 2, that's the function which we are looking at. Lower limit was equal to 5. Upper limit was equal to 8. Then that's the expression that we end up getting. So plus 8, 29.9146. Divide whole thing by 8. So let us try to do that together. Second quit. So clear. We have 1234.5073 plus 829.9146. Then that's the value we end up getting, but we have to divide that by 8. Therefore, our final answer will be 258 point. Now I'm just going to try to check what they want us to put it to the nearest of. Simply they told us to find the average rate, so I'm going to go for 0.53. Now they didn't even say they indicating the unit of measures, so we are okay so far. Number 3, find r prime of 3. Since 3 belongs to the first interval, we have to use this upper expression to find the derivative when t was equal to 3. So let's try to do that together. So once again, if I have to go back to the graph, second trace will get us the calculation. Since what we are looking for, as you can see, is the derivative, so we're going to go for number 6. The function that which we are looking at is this, as you can see, and the value of t that which we are looking at is 3. So we're going to plug in 3, and slope happened to be 50, basically. And so B, r prime of 3 is equal to 50. Now, when you can look into this one, correct unit. So basically, what we're looking at is liters per hour, and then we're dividing it by another time. So we have liters per hour, which means per hour square. Now, explain the meaning of the value in the context of the problem. So this is change of rate of change of water. when t is equal to 3. Alright, let's look at number C. Find, actually that's what we have done. This is C, sorry. And this was B. Okay, we're looking for D now. Write but do not solve an equation involving integral to find the time A when the amount of water in the tank is 9,000. So, how do we know if it's a 9,000 or not? Now, since R represents the amount of water that's being draining out, the fact that we have 9,000 in the tank, that means 3,000 has to be drained out. In other words, we are looking for R integral of R of t dt for some value from t0 through k. I don't know what k is, but that has to be equal to 3,000. And where k is time. Alright, and I believe time A, okay, we just have to change k into A. Alright, that's it. See you guys later. Bye.